So today is the first lesson of a couple of them where we are going to work on what's called an irrational approximation of irrational numbers. Okay, so some definitions here. This whole number is called a radical. The symbol here is the radical sign, and the number underneath is called a radicand. Okay, we use the word radical just because it's a more general description as opposed to just saying square root, which is specific. All right, the square root is one of two equal factors of the radicand. So in the one above, the square root of 9 is 3. Now we also know that negative 3 is also a square root of 9, because negative 3 times negative 3 is 9. But what we normally use in math is what's called the principal square root. And what is that? Every positive number has two square roots, a positive and a negative. A positive root is called the principal square root. Okay. So what we would say is, although we know the square root of 9 is 3 and negative 3, when answering any questions, we would say the square root of 9 is 3. If we wanted the negative, we would put a negative sign out there to say we want negative 3. Okay? All right. A cube root is one of three equal factors of the radicand. So again, the cube root of 8 is 2 because 2 times 2 times 2 is equal to 8. Okay. Then we have what's called a perfect square and a perfect cube. Perfect square is a positive real number. Can't be negative because we know that there is no square root of negative numbers in the real number system, whose square root is a rational number. And a perfect cube is a real number whose cube root is a rational number. You'll notice that we don't limit it to just positive numbers, and you're going to see that in a couple of minutes. Now, for today, what we're going to do is come up with the closest whole number to our roots. And as we go along over the next couple of lessons, we're going to fine-tune this to get even closer. So what is the, for example, what is the estimated value of radical 19? Well, we take a look and we know the perfect square below it is square root of 16. The perfect square above it is 25. So radical 19 is between the two of them. So this is 4. That's 5. It's closest to 4. So 4 is the closest whole number. Okay? Now we're going to do this today. That's what we're going to focus on, because if we don't understand how to do this part of it, then over the next couple of days it's going to be even more difficult. All right? So let's just get familiar again with our square or cube roots. We've got 7 here, 12. Now this is like the square root of 9 over the square root of 36, which is 3 over 6, which is 1/2. We did this before. That's 2, negative 30, and then 3/5. Now, estimate the square root based upon what it's closest in value to. So again, you've got to be comfortable with your perfect squares. This is between 36, helps to put it on the right side, it's between 25 and 36, so it's closest to radical 36, which is 6. This is between 81 and 100, and it's closest to the square root of 81, which is 9. This is between 49 and 64, closest to that, so 8. This is between 169 and 196. Okay, so that's closest to 169, so it's 13. And this is between 25 and 36, closest to 25, so 5. And then again, this is between 121 and 144, closest to 144, or 12. Sorry about that. So the objective today was to just get an idea of coming up with whole number approximations for square or cube, really square roots. Get a little bit more familiar with our perfect squares and perfect cubes, because we're going to be using them and refine our answers as we go along over the next few days.